The basic James Webb Space Telescope, JWST, marks a fundamental second in mankind's journey to reveal the secrets of the universe. This essential observatory, named to respect James Webb, a principal figure in NASA's set of experiences, addresses the peak of different broad stretches of coherent headway and worldwide collaboration. As mankind's most moderate space telescope to date, the JWST promises to change how we could decipher the universe and rethink the restrictions of actual assessment. Situated at the second Lagrange point, L2, around 1.5 million kilometers from Earth, the JWST offers an unmatched viewpoint on the universe. Dissimilar to its progenitor, the Hubble Space Telescope, HST, which circled Earth, the JWST's area ensures a consistent and unhindered perspective on the universe, freed from the bends achieved by Earth's air. This fundamental situating permits the JWST to dig profound into space, catching even the slightest signs from the most far-off divine articles. Outfitted with a scope of state-of-the-art instruments, the JWST flaunts unequaled capacities for noticing the universe across different frequencies, from close infrared to mid-infrared. Its essential mirror, contained 18 hexagonal fragments covered in gold, ranges an exceptional 6.5 m in width, giving splendid light social event power. Joined with best-in-class infrared finders and spectrographs, the JWST can distinguish the slightest blazes from far-off universes, stars, and exoplanets. One of the JWST's fundamental targets is to concentrate on the arrangement and development of worlds all through astronomical history. By looking billions of years into the past, the telescope can catch light from the earliest universes, offering experiences into the cycles that prompted the development of the huge designs we notice today. Moreover, the JWST's viewpoint on adjoining frameworks gives important information on star arrangement rates, heavenly masses, and the dispersion of dull matter, revealing insight into the vital drivers of universe advancement. Past its investigation of universes, the JWST is ready to reform how we comprehend exoplanets, planets circling stars outside our planetary group. With its better responsiveness than infrared radiation, the telescope can examine the environments of exoplanets, looking for indications of water, methane, and different particles that could show the presence of life. By performing transmission spectroscopy, which includes dissecting a planet's climate as it passes before its host star, the JWST intends to recognize possibly livable universes and study planetary variety. Also, the JWST's perceptions of our own planetary group give new experiences into the peace of planets, moons, and other divine bodies. By zeroing in on the climates of planets like Jupiter, Saturn, and Mars, the telescope offers essential data on barometrical peace, ecological circumstances, and surface elements. Besides, the JWST's perceptions of space rocks, comets, and other little bodies upgrade how we might interpret planetary group development and the starting points of planetary frameworks. Past its logical targets, the JWST encapsulates the soul of worldwide joint effort and helpful exertion coming about because of an organization between NASA, the European Space Office, ESA, and the Canadian Space Office, CSA. The telescope addresses an aggregate obligation to propelling human information and investigation by pooling assets, skill, and mechanical capacities. The JWST project represents the force of worldwide collaboration in resolving significant inquiries regarding our position in the universe. As the JWST leaves on its excursion of disclosure, it conveys with it the expectations and desires of incalculable researchers, designers, and space fans around the world. Each new finding and crucial revelation extends the skylines of human information and rouses people in the future to investigate the marvels of the universe. From disentangling the secrets of cosmic system development to looking for indications of extraterrestrial life, the JWST commitments to be a guide of logical advancement and a demonstration of humanity's unfathomable interest. This extraordinary disclosure and investigation of room have reliably broadened our grip of the universe, and presently we stand nearer than any time in recent memory to accomplishing this fundamental objective, on account of the James Webb Space Telescope. The telescope's sharp pictures of far-off systems are reshaping the way in which we decipher the universe in huge ways. Plan for a phenomenal time that started on December 25, 2021, when the JWST sent off from the Guyana Space Center. This best-in-class observatory, a cooperative exertion including NASA, ESA, and CSA, praises James Webb and adds one more part to NASA's tradition of investigation. The focal parts of the JWST program follow back to NASA's rich history of room research, expanding on the accomplishments of past missions like the Hubble Space Telescope, HST, send-off in 1990. The HST, an image of mankind's journey to grasp the universe, gave basic experiences and laid the basis for the aggressive JWST mission. The HST was intended to conquer the restrictions forced by Earth's climate, circling in low Earth circle around 340 kilometers over the surface. It used progressed reflect innovation and accuracy instruments to catch and break down light from divine articles with wonderful lucidity. All through its main goal, the HST caught shocking pictures and gave fundamental logical information, altogether adding to how we might interpret the universe. Its remarkable achievements incorporate uncovering tremendous measures of vast designs in apparently void space, showing star development in the mainstays of creation, and uncovering the ultra-profound field, uncovering systems as far back as the early universe. The HST likewise assumed a critical part in finding exoplanets, noticing grandiose impacts, and affirming key cosmological hypotheses, like the enormous detonation, by zeroing in on far-off universes and vast foundation radiation. The HST gave decisive proof supporting the hypothesis of the universe's starting point and added to estimating the pace of inestimable extension through redshift perceptions. Presently, with the JWST recognizing light from one more system 7 trillion miles away, the splendor of inestimable investigation is being renewed. As we dive into the ramifications of this phenomenal disclosure, we proceed with the practice of disentangling the secrets of the universe. The information gathered has uncovered an enthralling part of our universe. Systems farther away are withdrawing from us at higher rates, affirming the development we had expected. The Hubble Space Telescope assumed a major part in refining how we might interpret this development, especially through the Hubble study, which estimates the rate at which the universe is not set in stone by cosmologist Edwin Hubble during the 1920s. Resulting perceptions from Hubble refine the study, albeit ongoing estimations have prompted a few disparities. These experiences, close by staggering pictures, have extended our astronomical information past what Hubble could give. NASA's disclosing of the James Webb Space Telescope denotes an urgent accomplishment in space research. NASA's broad endeavors, from Mars Meander missions to Explorer missions, added to the mechanical headways important for the JWST's turn of events. The send-off of the JWST carries us nearer to grasping the nature, starting points, and destiny of the universe. Not at all like its ancestor, the JWST catches long-frequency infrared light, giving a more extensive and more clear, inestimable view. One more critical disclosure by the JWST incorporates distinguishing light from a planet 7 trillion miles away, testing existing speculations. This finding recommends that the planet WASP-96b could hold onto extraterrestrial life, lighting energy, and interest in the chance of outsider life past our planetary group. This disclosure, at such an inconceivable distance, features the JWST's momentous observational abilities, intended to outperform Hubble. The JWST can look through thick residue mists, uncovering stowed away inestimable peculiarities with its 6.5 m essential mirror made of gold-plated beryllium. High-level infrared cameras and a bleeding-edge sunshield permit the JWST to work at incredibly cool temperatures, fundamental for its infrared perceptions. With its outstanding capacities and high-level instruments, the JWST beats past observatories, improving our capacity to investigate the universe. One of its essential targets is to zero in on the airs of exoplanets, looking for indications of tenability and key atoms like water and methane. By breaking down radiation from tremendous distances, the JWST likewise thinks back in time, catching light from antiquated worlds, stars, and astronomical designs shaped billions of years prior, unwinding the universe's beginnings and advancement. Past our nearby planet group, The JWST mission reaches out to concentrating on the elements of enormous advancement, including the recognizable universe's turn of events. The telescope has made huge revelations, reshaping how we might interpret the universe. Among these is the striking picture of Stephan's quintet, a gathering of 5 worlds around 290 million light-years away, where 4 universes communicate in an enormous grandiose dance, uncovering gravitational connections and impacts. These perceptions give bits of knowledge into galaxial development, star arrangement, and the slippery idea of dim matter. The JWST likewise caught a point-by-point picture of the Carina Cloud, a star-framing locale around 7,600 light-years away, highlighting gas, dust, and heavenly nurseries, featuring the development of new stars, including 8Ba Cainii, a parallel star framework with a charming history. The JWST's new picture offers unmatched lucidity, supporting the investigation of star development and cloud structure. The perception of the Southern Ring Cloud, otherwise called the Hourglass Cloud, situated around 2,500 light-years away, uncovered the second star in the cloud's parallel framework, upgrading how we might interpret its design and qualities. Moreover, a striking profound field picture highlighting the world bunch SMACS 0723, exhibiting systems around 5 billion light-years away, furnishes space experts with an extraordinary chance to concentrate on universe development and development in the early universe. The experiences acquired from this far-off cosmic system group fundamentally add to disentangling the mind-boggling processes driving world arrangement, assisting us with getting a handle on the stupendous story that has molded the range of designs saw in the universe today. These disclosures feature the JWST's critical effect on space science, pushing the limits of observational abilities and giving important experiences into far-off divine items, system development, exoplanet conditions, and the early universe. These disclosures have roused laid-out researchers, opening the entryway for additional investigation and revelations. With this excellent space observatory, there is still a lot to reveal. The potential for extraterrestrial life and the chance of first contact are